Okay. Teacher. All right. Good morning, everybody. Let's go ahead and get started. Let's see. It's 11:30. This is a little bit strange for me because normally when I teach science, I can see my students and I can ask them questions. So it's a little bit different for me. However, if you do have a question, I ask you to please type it here, and that way I can read. But let's go ahead and get started. We're talking today about chemical reactions. I want to move on and really start working on slide 3. So if everyone could join me on slide 3. Oh, they can. They see everything right there in real time. Okay, all right, terrific. Okay, so let's look at that slide. We've got a picture of a room. And over on the left, the world around us contains many different materials. How many different materials can you see in this bedroom? So, well, let's look at some of those materials. What about the golf club? What type of material would that be? Yes, many. Very good pair. All right, I don't want to see any tie here. I want English answers. How about, let's start with the golf club. What type of material? Starts with an M. Here I will. M. Met. Okay, it's a metal. Very good. So I want you to practice using this form. Yes, I'm Douglas. Oh, are you Douglas? Who's that? Oh, okay. Yeah, that's right. Some of my old students might be joining me. That's terrific. All right. So, is that Kong? Okay. All right. So I want you to practice using this form. I'm going to type it there into the box. The golf club is made of metal. This is the form we use in English when we describe an object and its material. So I want you all to practice using this form with the other objects in the room. All right, let's take, for example, the poster. What is the material of the poster? Very good. Chemajo? Paper. Excellent. So let's see a complete sentence. Yeah, it's not a metal. Very good. Tell me let's use a complete sentence. Use the form that I used earlier, the 1137. How would I talk about the poster? I don't see an answer. Come on. Okay, I'll give you 3, 2, 1. Here it is. The poster. Oh, what? Metal? No. Sorry. There we go. The poster is made of paper. All right, how about another example? Let's use the socks. What is the material of the socks? Cotton. Very good. All right, so I want to see a complete sentence about the socks. Very good. Excellent. Araya? Yeah. That's correct. The socks are made of cotton. Remember to use are because we're talking about 2, not just 1. Terrific. And let's do one more. Let's take the window. How about the window? What is the material of the window? Perth, very good, excellent. Mirajong, you were close. Watch that L and the R. Glass, good. So, who can give me a complete sentence? Excellent pair. Yes, the window is made of glass. The window is made of glass. Beautiful. All right, let's move on. Slide 3. We're missing some letters on that slide. Materials can be changed in different ways. A physical change means a material changes size, shape, or state of matter. For example, ice melts at room temperature. Ice. The window is made of glass. Good. Let's look at that ice. What state of matter is ice in? Very good. Perth. Solid, solid, solid. Excellent. So how can we describe that in a complete sentence? A complete English sentence. We would say, ice is a solid. What about the water? When the ice melts, what would we say about water? What state of matter is that? Liquid. Good. I want to see a complete sentence. Water is a liquid. Excellent, Araya. Good work. What about if the room gets very hot and the water evaporates? All right, air, not quite. We would say a gas. Good. So how about not air as a gas? We would say water vapor or steam is a gas. Excellent. All right. So we know our different states of matter. Solid, liquid, gas. Now, how do we talk about the changes from one state to another? We have four words that we're going to use there. Let's look at that, the ice, for example. Let's say I have ice. I'm going to write a sentence here. There we go. Ice blank water. So when ice becomes water, when a solid becomes a liquid, what's the word we use there? Melt. Good. All right. So let's make a complete sentence there. Ice melts, and there's one more word we need. Starts with an I. Ice melt. Very good, Araya. Very close. We're going to say ice melts into water. We can also use the words we learned for the states of matter and say something like this. A solid melts into a liquid. Alright? Let's do a couple more examples. What about if that water gets hotter and becomes vapor? Evaporation, very good. Chema Jodi. So how about a complete sentence there? Okay. We've got the right word, evaporate. We're going to use this word. Evaporate. So how about a complete sentence? Tell me about going from water to gas, or from a liquid to a gas. So we'll say water there. Water evaporates into vapor. Good. A liquid evaporates into a gas. Pair, that's another way of saying it. Terrific. What about when that vapor gets cool again? and the molecules start moving slower, and that gas becomes a liquid. What do we say when a gas becomes a liquid? What do we say for this? A gas to a liquid. Okay, condensation. Let's use the verb. Condensation is a noun. Our verb would be condense. So how about a complete sentence for water vapor and water? You say water vapor. There we go. That's our sentence. I want to see somebody give me an answer. Fill in the blanks. Okay, Mamu, good. But I want you to use the words that I used. Water vapor, condense into water. Very good. And remember, we're going to say water vapor condenses into water. Remember, in English, we have to conjugate those verbs based on the subject. Water vapor condenses into water. Very good. Namo, watch the spelling. It's an S, not a C. Oh, yes. Good. All right. So that water vapor condenses into water. What about when that water gets even colder? When we go from a liquid to a solid, what do we call that? So what's our word going from a liquid to a solid? So from water, yeah, good, Perth. From water to ice, freeze. Excellent. So how about a complete sentence using water and ice? And remember to conjugate the verb. All right, I want a complete sentence. Water perfect, Araya. Water freezes into ice. Excellent. That's what I'm looking for. So we know that when the water molecules when they become cold, the molecules move very slowly and they start to form a crystal. So they go from being a liquid to a solid, from the liquid state to the solid state. And the word for that is freezing. And that's, yeah, terrific, Araya. Water freezes into ice. That's the form that I want you to use when you talk about state changes. All right? We got physical change, easy to reverse. What is the reverse of ice? All right, let's look at the last question on that slide. Reverse. What do you think that means? Reverse. Where we go? Reverse means to go the other way. What we'll do, yeah, like that. Look at those two arrows I drew. That's reverse. So let's look at that last question. What is the reverse of ice melting? What is the reverse of ice melting? Close, pair. Not ice freezing. Ice freezing? Ice is already frozen. Cold ice. All ice is cold, pair. Water freezing. So we've got water freezing, ice melting. Exactly, yeah. Water freezing, ice melting. Water evaporating, vapor condensing. All right, let's move on. Where is my mouse? Ah, there we go. All right. Next up. All right, so we've talked about physical changes. We know our three states of matter and our four types of physical change. There is a fifth one, but I'm not going to talk about it in this lesson. Now let's move on from physical changes to chemical changes. All right. When we have chemical changes, we're talking about making new molecules. What's the answer? Water freezing. Freezing water. What answer? When we talk about chemical changes, we're actually talking about creating new molecules. So I'm going to write that down. Chemical change. Creating new molecules. So let's talk about molecules. Well, we've been talking about water, so maybe one of you can tell me about a water molecule. What do we have in a water molecule? What's a water molecule made of? Any idea? What's in a water molecule? All right. Well, let's step back a ways. Let's talk about a few types of elements. I want to hear from you. Please tell me the names of some different elements. I'll give you one example is oxygen. Iron. Very good. C. H. Not just the letter. Okay, water is not an element. That's what we're going to talk about here. Carbon. Good. Iron, oxygen, carbon, hydrogen. Very good. Yeah, okay. That's excellent. That's enough. That's all we need to talk about right now. Carbon, oxygen, hydrogen, iron, argon. Okay, good. Helium. Very good, Top. All right, that's enough. No more elements. So we've got some of our elements. Let's look at two of those. Hydrogen and oxygen. Two of our elements. Now, we know that when we have a chemical change, we're creating new molecules. And we know that molecules are made of atoms. Very good. Okay, S29, 626, you're getting ahead of me. My next question is about water molecules, because we've been talking about water during this lesson. I think you all understand it. Well, we know H2O, but what does that actually mean? What can we say about a water molecule? Right? There's our sentence. All right, yeah, H2O, H2O. What is that? All right, well, let's take it in two parts. First, let's look at the H2. What does that mean? Okay, 2 hydrogen, 1 oxygen. Let's say, well, 2, very good, very good. Let's say 2 hydrogen atoms and 1 oxygen atom. So we know that a water molecule has 2 hydrogen atoms and 1 oxygen atom. We also, how about another one? One oxygen. What about carbon dioxide? How about carbon dioxide? What do we have in a carbon dioxide molecule? And I would like to see a complete sentence there. We'll say what? A carbon dioxide, molecule. I did not mean to skip to the next one. Very good, TT. One carbon atom and two oxygen atoms. Perth, remember, it's not one carbon molecule, it's one carbon atom. Carbon is an element. So our complete sentence there, what? Yeah, one carbon atom and two oxygen atoms. So our complete sentence there, what? A carbon dioxide molecule has one carbon atom and two oxygen atoms. So when we have a chemical change, we are actually creating new molecules by moving some of those atoms around. Now, when we have that molecule, that verb, a carbon dioxide. Oh, here, I will type the complete sentence for you. What? Dang it. Here. A carbon dioxide. There we go. A carbon dioxide molecule has one carbon atom and two oxygen atoms. Now, when we talk about molecules, we say that the atoms are bonded. The atoms form a bond. When we have a chemical reaction, we are breaking bonds or creating new bonds. So in carbon dioxide, the oxygen bonds to carbon. In water, hydrogen bonds to oxygen. And when we have a chemical reaction, we are either breaking bonds or making new ones. Breaking. Here we go. Creating. There we go. We're either breaking bonds or creating new bonds. All right, let's move on. Let's look at the example that they give. A bicycle left outside has become rusty. What is rust? What has happened here? That bicycle, all right. What element is the bicycle made of? Remember, at the very beginning of our lesson, we talked about, we looked at different materials. We said, for example, here. Okay, metal, very good. Remember, we said the window is made of glass. The bicycle is made of metal. But I want you to tell me now, what element, what is the name? Starts with an I. Good, Araya. Iron. So I want a complete sentence. Tell me about the material of the bicycle. And use the form that I have here. Use the same form I just used. There's our sentence. I want somebody to give me a complete... Excellent, Perth. Excellent, Nat. The bicycle is made of iron. Good. Jane and Nat, you don't need the up. You can just say, you can use the form that Perth used. The bicycle is made of iron. That's all you need to say. Good, good, terrific. Okay, that iron in the bicycle, when a bicycle rusts, the iron bonds to oxygen in the atmosphere, and it forms here iron. There we go. We get iron plus oxygen, and that forms a new bond. We make a new compound called FeO, or iron oxide. Remember, we had carbon dioxide, carbon bonded to two oxygens. Here we have iron oxide, an iron atom bonding with oxygen. And iron oxide is rust. Okay, so a chemical change is very difficult to reverse. Could you change a rusty bicycle back into a non-rusty one? In this case, no. You can't go back and forth. You can't just break the bond and have your iron magically replaced. Yeah, oxidation. Terrific. Excellent. Excellent. Let's move on. We got chemical changes, react. Aha. Okay, let's go to slide 7. A chemical change is called a chemical reaction. A chemical reaction can be shown by a word equation, reactants and products. Let's go into the example of the bicycle. What are our reactants? Let's look at that oxidation rate. What are the reactants? There are two. What are the two reactants in the example of the rusty bicycle? Oxygen and iron. Terrific. Correct, TT. What is our product? We have one product there. Yeah, FeO or iron oxide or rust. All the same thing. Yeah. So in the case of the bicycle, iron and oxygen are our reactants, and the iron oxide, the rust, is the product. All right. Terrific. I think that's easy, right? Easy? Good. All right. Yes, yes. All right, then let's move on. Let's make it a little bit more difficult. All right, here we go. The formation of water. I don't know, is this video working? I could not get it to work a moment ago. Ooh. Here, okay. So for the formation of water, we have hydrogen and oxygen equals water. What are the reactants? Oh. Hydrogen and oxygen. Very good. And because this is an English science class, I want someone to give me a complete English sentence. Tell me about the reactants and the product of this reaction in a complete sentence. I'll say... Oh, sure, thank you. Use that form. Yes, 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 easy. Alright, so in this, alright, the reactants are hydrogen and oxygen, and the product is water. Very good. And remember, I want you to notice, please remember the difference between the are and the is. That's just a little English grammar I want you to practice. Because we have two reactants, so we use are. And we have one product, so we use is. Okie dokie. Ha ha ha. Alright, let's move on. Okay, tell you what, let's take a little quiz. Number one, in a chemical reaction, the properties of the reactants and the products are what? What do you think? The properties. Well, let's look at rust. Is rust anything like iron? Correct. Very different. Look, rust is a different color. It's a different texture. Everything about rust is different from iron. We can build bridges out of iron, but we could never build a bridge out of rust. So the properties are very different. All right, number two. When a chemical reaction takes place, the products can be turned back into reactants. What? Very easily or with difficulty? Correct. With difficulty. Now remember, when we change, say, the state of matter, when we have a physical change, like water freezing into ice, that can be changed very easily. Ice melts into water. But a chemical change where oxygen and iron bond to form rust, that it's very difficult to go the other way. When a bond is formed, it's often very difficult to break that bond with a magic wand. That's the joke answer. All right, let's look at the next one. The speed of a chemical reaction. What do you think? Very slow, very fast, or it changes? Well, let's look at another chemical reaction. Yeah, very good. C. It can be slow or it can be fast. Let's look at two examples. Think about the bicycle. Now, when our bicycle rusts, we get iron. What the heck? With our bicycle, iron plus oxygen equals iron oxide. But does that happen all at once? If I leave my bike out in the rain and I walk out the next day, the bicycle will not be covered in rust. It takes days or weeks or months for that to happen. However, if I take a piece of magnesium, if I burn magnesium to form magnesium oxide, that will happen very quickly. If you take a strip of magnesium and burn it, it happens in an instant. So iron bonding to oxygen to make iron oxide is very slow, but the magnesium bonding to oxygen to make magnesium oxide is very fast. So for number three, the speed of a chemical reaction can range from very slow to very fast. All right. Number four, the products of a chemical reaction are shown on the left-hand side of a word equation. Always, sometimes, or on Thursdays. Products are shown on the right. Products are shown on the right. Number 4, the products of a chemical reaction are shown on the left. It should be never. Yeah. Yeah. All right. With number 4, there's a little bit of a mistake. The products, the answer should be never. The products are never on the left. Products are going to be on the right. All right. Let's move on. We don't need to worry about that too much. Okay. I would like you to look through the rest of these questions on your own, but for the time being, I'm going to skip ahead to number 9. Sodium metal is heated. It can react with chlorine gas. What is the product of this reaction? Number 9. Number 9. Yeah. What? Huh? Correct. C. Sodium chloride is the product. These are our reactants. This is the product. Sodium chloride. We write that like this. Sodium chloride. This is a compound we use every day. What's another word for sodium chloride? We use it in food. Salt. Correct. Yes, salt. So you can see, and this is a good example. Remember, here, let's go back to number 1. The properties of the reactants and the products are very different. In the case of salt, our reactants, sodium and chlorine, they're both poisonous. They're poisonous to human beings. We do need sodium, but we can't just breathe sodium gas. However, when sodium bonds to chlorine, we get salt, which is a chemical that is not poisonous for us. So again, an example of the salt having properties that are very different from sodium or chlorine. So the product has properties very different from the two reactants. All right. Easy? Reactions with acid. Let's move on. Fun stuff. Okay. First of all, what is an acid? Now, we named some different elements before. Hydrogen, oxygen, carbon, iron, zinc, whatever. In an acid, which of these elements do we always have? What element in any acid reaction, what's the element in that compound that's breaking its bond? What's the bond that breaks in an acid reaction? It's a bond with hydrogen. Hydrogen is the important element here. And keeping that in mind, let's go on. What do we know about acids? All right, so lemon juice, vinegar, they're harmless. We use them in our food. Our body uses acid. Our stomach is full of acid. Strong acids must be handled with care because they can be dangerous. They can be harmful. Now, why are acids harmful? What do we know about chemical reactions of metal? All right. Acids can be harmful because they can react with the compounds in our bodies, in our skin, for example. And they can create chemical reactions with our skin that we don't want. All right. Let's move on. We need to know about the chemical reactions of acids with metals and carbonates. All right, terrific. Let's start with metals. Let's start by naming a few metals. I want to hear from you. Tell me the names of some different metals. We've already talked about iron, so I'm going to write that one down. What are some other metals? Come on, gang, wake up. We've got, how about aluminum? Or copper? Zinc. Somebody beat me to it. Good. Zinc. Iron, copper, zinc, aluminum. Tin. All right. Good. You know what a metal is. They are strong. They are solid. They are shiny. I like that. Solid. There is only one metal that is not solid. Yet platinum. There's one metal that is a liquid at room temperature. Do you know what it is? Oh, Perth. Yes. Good. Mercury. Hg. Mercury. Okay. Just a trivia point for you today. All right. So we know that when metals react with acids, this particular type of reaction is called corrosion. Now, I don't want to get into ionic and covalent bonds, so I don't think we really need to worry about that right now. All right, so metals can be changed into new substances. We already saw one good example, the rust. That metal, iron, bonding to oxygen to create iron oxide. So metals can be changed into new substances. That's an example of a metal bonding with oxygen. When metals react with acids, this is called corrosion. Let's look at an example. All right. Do all metals react with acids the same way? Well, no. We can see that sodium reacts very violently. We see a flame coming off of the sodium, which means that when sodium reacts with an acid, heat is being released. So what type of reaction is it? We know that we can see that heat is released, which means that chemical energy is converted into heat energy. So what type of reaction starts with an E? Ends with a C. No? What type of reaction? When sodium reacts with an acid? Energetic. The word I'm looking for is exothermic. Energy is being released there. And I will write a complete sentence for you. This is how we describe it. In an exothermic reaction, heat is released. Okay. But let's look at some of those other ones. The magnesium, the iron, and the lead. In all of those, we're getting bubbles. What does that mean? We have let me step back. We have these metals. All right, terrific. That's what I'm looking for. Our metals: sodium, magnesium, and iron, and lead. They are all solid. Our acids are all liquids. But what we know that one of the products is a gas because we see the bubbles. All right, so if we see bubbles, then one of our products must be a gas. And on that note, let's go to the next slide. When a metal reacts with an acid, the metal gets smaller and it seems to disappear. Now, what does that mean? If the piece of metal seems to get smaller, that means that the metal atoms are leaving. They're going off and forming new bonds. But as the metal disappeared, the metal has reacted with some of the acid. All right. The products of this chemical reaction are a salt and the gas hydrogen. There we go. So, complete the word equation for the reaction. So what is our gas? Those gas bubbles that we saw coming off of the metal. Which gas? CO2. That's a good guess. I'm actually going to talk about that. But remember, we see here the products of the reaction are salt and the gas hydrogen. So we get bubbles of hydrogen gas. Now the CO2, I said, that is a good guess. We're going to talk about that in our next example. So let's complete that table at the bottom of the slide. If we've got here a metal plus an acid, these are our products. So what are our reactants? Oh, sorry, these are our reactants. What are the products? Our reactants are metal and acid. Here. Metal plus acid equals there. A metal plus an acid equals hydrogen gas and a salt, like sodium chloride. So here, yeah. Our reactants, metal and acid. Our products are hydrogen gas and salt. Let's move on. Carbonates. Here, we're going to talk about the CO2. Carbonates are chemicals that contain carbon and oxygen, like CO2. A carbonate. Carbonates can react with acids. Watch what happens to the lime water with calcium carbonate. Now, what is our formula for calcium carbonate? CaCO. I believe it's calcium carbonate. CaCO3. Now, let's look at what happens when that calcium carbonate reacts with an acid. Calcium carbonate reacts with the acid to produce a gas, which turns the water cloudy. What is the name of the gas? Exactly, yes. Carbon dioxide. Good. To give you an example, let's say CaCO3 plus, and we'll take an acid like sulfuric acid, which would be H2SO4. Here, that would be calcium carbonate with sulfuric acid. So what happens? We get a salt plus water, H2O, plus hydrogen gas, plus, oh wait, sorry, no hydrogen gas. I made a mistake there. Plus CO2. Yeah. No H, sorry. So our three products there are salt, water, and CO2. Okie dokie. So there we got our reactions. We've got our corrosion. We've got a reaction with metals. We've got our reaction with carbonates. Now let's look at reactions with oxygen. Oh, end. Burning. Burning is a chemical reaction. When things burn, they react with oxygen in the air, and energy is released in the form of heat and light. I already gave you an example of this. When you burn magnesium to get magnesium oxide, that's an example of combustion. How about another example? What else would combust? Alright, so magnesium, we'll stick with magnesium oxide. Let's look at the bottom of the slide. Can you name 3 things needed for combustion? 3 things. Well, we know one of them is oxygen. We're going to need oxygen. Alright. Not hydrogen. We're going to need oxygen. What else? Metal plus acid. Well, in the case of magnesium, that magnesium is called our fuel. We need something to burn. If we burn a piece of paper or we burn a piece of wood, that's called our fuel. So we need oxygen. We need fuel. What else do we need? Well, right here, I've got oxygen in this room. I have paper in this room. Why isn't the paper combusting? Why is it not burning? Because we don't have any heat energy to make it burn. So, we need, let's look at this triangle. We talked about oxygen, fuel, that third side to the triangle on the right, the heat energy. Some energy needed to start the burning reaction. And in chemistry, we call this our activation energy. Alright, so we talked about what? Corrosion, talked about carbonates, and we talked about combustion. Why don't we go ahead and wrap it up there for today? That's 1 hour. Yeah. Yeah. Sure. Okie dokie. All right, so thank you, everybody. All right.
Water, coffee.
Actually, a cup of coffee would be great.
Yeah, I'll get you one. Don't worry. โอเคครูดักลาพักแป๊บหนึ่งนะ10 นาทีท็อปิก chemical reaction หมดแล้วนะครับอันนั้นของม2เดี๋ยวเราจะสอนวิทย์ม1เรื่องelement compound กับ mixture ใครจะอยู่ฟังต่อก็ได้นะโอเคนะครับเดี๋ยวอีก10 นาทีโอเค
Is this the same student?
maybe same maybe different some of them like to they don't have anything to do what's up oh you need
Yeah, I wanted to go.
take a look at it
Yeah.
Sure.
Just a couple more notes, reactants, elements.
That's pretty good too. It's something natural. Except that just it's not a lot of feedback. That's the only downside.
Yeah, it's kind of weird. Like when I'm talking, it's hard for me to gauge the reactions. And I'm in front of students, I can see if they're confused or if they're.
The system has the other end's webcams and they can talk to you, but Thai students they don't really like you. They just like to chat. So yeah. ต่อไปเป็นพิษเกี่ยวกับเรื่อง compound mixture นะครับใครอยากจะอยู่ต่อก็ได้มีคำถาม compound mixture กับ element มันก็ของม2กับม1ด้วยกันแหละโอเค